Hello, hello, hello. This is Chris Ferdinandi from GoMakeThings.com. Last week, we talked about how to run JavaScript tests without using any sort of build setup. So no node required, no need to open up a terminal and run anything, just a web browser where you can run some tests and see them pass or not. Today, I wanted to dig into how you actually write unit tests, because one of the things I hear come up from folks a lot is that testing is often talked about at a hypothetical level, but it's really hard to find resources that show how to actually write them. So today we're going to look at how to write some unit tests, and we're also going to talk a little bit about how to structure those tests. Just really quick, if you find this sort of thing interesting, please feel free to like the video, leave a comment, subscribe. If you have any questions, I'd love if you ask those down in the comment section, because I do read all of those and we'll answer them, use them for future videos. YouTube likes it, which is great. And also, if you want to dive deeper into topics like this, you might want to consider signing up for the Lean Web Club, which is my course, code, and community platform where I have a ton of courses, workshops, and reference guides on topics just like this. You can bookmark your favorites so you can access them again easily later. And I have a whole toolkit of stuff, including a JavaScript testing suite that you can use to start testing your code. So with that out of the way, let's dig into it. So I have a calculator app. It's got some functions for adding, subtracting, multiplying, and dividing code, and I want to test it. When you are using a JavaScript testing library, you're working with assertions. Assertions are functions that use plain language to describe what you're trying to test and what the expected outcome or result should be. And the specific words that you use for your assertions is going to vary from one testing library to another. But for the one we're using, Chai, it has a whole documentation on what it should look like, and I'm going to show you an actual example. So here, I am saying that I expect the output of the add function to equal, and then in this case, it's the number 18, because I'm adding 4, 6, and 8, and that should total 18. In this case, I expect that if I add 42 to nothing, it should equal 42, and so on. So you write your tests in this manner. Most libraries have the negative version of this, so I would expect it to not equal 18, for example. But general guidance is that you want to check equals more than not equals. So checking that something doesn't equal a thing you're looking for is usually kind of an anti-pattern. There are some situations where you might use it, but there are a lot of different things that you could test. So not just equality. They have some helper methods. So if it should equal true or false, they have some shorthands for that, or nan. And then they also have things like if you want to make sure that it contains, that it's a string, that there's only one of them. So they have a whole bunch of different kind of methods that you can use to check things. I tend to write my tests very simply. So I'm doing some things and then making sure they equal some other things. So that's kind of step one here. The other piece for our particular setup, where we're going fully buildless, I am loading the Chai library, and then inside my test, I need to use object destructuring to pull the expect method out of it. And so to actually run the tests, you use the it method, where you pass in a string that describes the thing you're testing. So in this case, it should add 2 or more numbers together. And then I pass in a callback function that runs my actual assertions. And so the expectation is it should add 2 or more numbers together. I expect that when I add 4, 6, and 8, it will equal 18. It should return the original value when only one number is provided. I expect that when I add 42 with no other arguments, it should equal 42. It should return 0 if no numbers are provided. And I expect that when I run the add function with no arguments, the output should equal 0. And you can see I've repeated that with all of my different tests. When we jump over to the actual HTML file that's running all of this stuff, I have all of my methods passing, and you can see it actually, it has those things that we described. So the it should add 2 or more numbers together with a check, and it'll actually show you the specific code for that if you click in on any of these. So it'll act like a little accordion and expand or collapse. One other thing I wanted to dig into is how you actually organize your JavaScript tests. So every library is going to have a slightly different way of handling this, but in Mocha, which is what we are using as our testing framework, they use the describe method. And so this method is literally a place for you to describe the thing you're testing. Just like with it, you pass in a string that describes it, and then a function that runs all of your different tests. So I am describing the add method. I am describing the subtract method, the multiply method, and so on. And these can be nested within each other. So here I am describing the calculator.js library, and then I'm describing each of my individual methods. And you can see in the UI here, you get this descending order of headings that adds a little bit of structure and organization to your tests. You can even dig in on just some specific portions if you want to by clicking in on them. So that's one aspect of it. The other aspect of how you organize your tests is you will typically see JavaScript tests include the word test in their name, as well as the library or bundle of code that they're testing. So test.calculator.js or calculator.test.js, depending on just kind of conventions within your team or whichever one you like best. So you don't typically want to include all of your tests for all of your different files in just a single test file. You could, some people do it, but it tends to make things a little bit easier if you keep them in separate files with a consistent naming convention. You will also see that a lot of times folks will have a specific directory like tests where they keep all of these files. So rather than having it just kind of out in the main directory, all of the tests sit within their own separate directory, which makes them a little bit easier to find, and just kind of keeps them out with the rest of the main JavaScript code. So those are kind of the big things around writing unit tests and kind of keeping them organized and structured. This doesn't have to be complicated. A lot of stuff you'll see online makes this really complicated, but it doesn't have to be. You can keep it super simple if you want to. And I actually think that's a really good idea if you're trying to make your tests fast and simple and easy to write. In our next video, we're actually going to look at TDD, or test-driven development, and how to do that in a way that is easy, painless, and actually makes it faster and easier to write code rather than being a hindrance. Because I think a lot of folks, myself included, historically have found that TDD feels like more of a roadblock than a help. And I recently saw a video and dug into some resources that completely rewired my brain around this. So I want to share those with you as well. That's it for today. If you liked it, give it a thumbs up, subscribe, share, comment, all that great stuff. It makes YouTube happy. If you want to dig more into topics like this, go check out the Lean Web Club. You can join with a free month trial over at leanwebclub.com. I think you're going to love it. And I will see you next time. Cheers.